In this experiment, you will be adding bleach to a solution of blue dye and monitoring the chemical reaction using the SpectroVis spectrophotometer and Logger Pro software. Once you have signed into the computer, launch the Logger Pro software. If the green button is not illuminated, plug the SpectroVis into another USB port on the computer, close Logger Pro, and reopen the software. The Collect button should be green, and the spectrum of visible colors should be in the background. Rinse the cuvette with deionized water. Fill the cuvette with deionized water. Place the cuvette in the SpectroVis and calibrate. This zeroes the absorbance with water as the blank. Allow the lamp the full amount of time to warm up, then press Finish Calibration and OK. And again, at this point, your absorbance should be reading 0. Set the experiment to absorbance versus time. Be sure to select the lambda max of the blue dye. This is the same blue dye used in experiment 3, which had a lambda max of approximately 630 nanometers. Be sure to choose a lambda max closest to the value you reported in experiment 3. Set the collection length to 600 seconds and allow for continuous collection. You will not need the full 600 seconds, but it is important to set the limit for longer than what you need to ensure that your data collection is not automatically stopped prematurely. For your first trial, you will be combining 20 milliliters of blue dye, 4 milliliters of water, and 1 milliliter of bleach. Squeeze roughly 40 milliliters of blue dye into the 50 milliliter beaker. Using the 20 milliliter volumetric pipette, transfer 20 milliliters of the blue dye from the beaker to the dry Erlenmeyer flask. There will be 2 burettes available, one to dispense water and the other to dispense bleach. Pay attention to the labels on the burettes. The burettes should be clean and dry, but check with your instructor to see if they need to be prepared. If so, you should rinse the burette labeled water with water and the burette labeled bleach with bleach. Remember, for this trial, you only need to dispense roughly 4 milliliters of water and 1 milliliter of bleach, so do not fill the burettes completely. Remember, burettes are accurate to 2 decimal places, so when you are asked to dispense 4.0 milliliters, this means you can transfer anywhere from 3.96 to 4.04 milliliters. You always need to record the burette readings. For this experiment, it is recommended that once you have added the bleach and water to the respective burettes, that you lower the liquid so that the initial reading on either burette is to 0.00. This will eliminate any complication in the dispensing of the desired volume. When setting the desired starting point on the burette, be sure to check for and eliminate any air bubbles in the burette. Using the water-containing burette, dispense 4.0 milliliters of water directly into the Erlenmeyer flask containing the 20 milliliters of stock solution. Record the burette readings before and after dispensing. Using the bleach-containing burette, dispense 1.0 milliliters of bleach directly into the Erlenmeyer flask containing the 20 ml of stock solution and the 4 milliliters of water. Be sure to have recorded the initial reading on the burette before dispensing. Immediately mix and swirl the reaction mixture for a few seconds. Empty the cuvette into the waste beaker, rinse the cuvette with the reaction mixture, fill the cuvette with the reaction mixture, clean with a Kim wipe, and place the cuvette in the SpectroVis and push Collect. At this point, you should see data collecting in the columns on the left and the decay curve appearing on screen. You should also take this time to read the final burette reading for the bleach and mark it down. When the 600 seconds is up, the data will stop recording and you should see a decay curve which looks roughly like what is shown on screen. Note that you do not have to wait the entire 600 seconds. It is recommended to stop the collection once the absorbance has reached 25% of its initial reading. For example, if the initial absorbance of this experiment was roughly 0.600, then the experiments could be stopped after the absorbance is lower than 0.150. Export your data as a CSV file. This will allow you to manipulate your data in Excel.